In this example, we have a block sliding down an inclined board. Now remember what's already been discussed in the text. We can always split vectors up into any two perpendicular components. It doesn't make sense to work horizontal and vertical here because the box is not sliding horizontally or vertically. It's sliding along the incline. So we're going to deal with our vectors as either parallel or perpendicular to that incline. Those are the two dimensions we'll consider in this problem. Now I already showed you how to take the weight and split it up into two components, one that's parallel and one that's perpendicular to the incline. The parallel component is the weight times the sine of the angle of the incline, and the perpendicular component is the weight times the cosine of the angle of the incline. There are two other forces to worry about. First, there's friction. I've labeled it little f. It opposes the motion, and since the motion is going on parallel to the incline, it is also parallel to the incline, but it's pointed up the incline rather than down. There's also the normal force. The normal force is always perpendicular to the surface, so it's automatically perpendicular to the incline, and it's fighting W cosine theta to make sure that the box doesn't fall through the board. Okay, we're given a few facts here. We know that the weight of the box is 35 newtons. We know that the angle of the incline is 30.0 degrees. And we know that the coefficient of kinetic friction is 0.12. And the question is, what's the acceleration of the block? All right, to get the acceleration, we're going to have to concentrate on the dimension that's parallel to the incline, because that's where the acceleration is occurring. But look at the forces there. One of the forces is weight times the sine of theta. That's fine. We know both of those things. We know the weight and we know theta. However, the other one is the friction. And we don't know the friction. What do we have to do to get the friction? We have to know the normal force. So we're going to have to deal with the perpendicular dimension just to figure out what the normal force is. So we might as well start there. In the perpendicular dimension, there are two forces. The normal force, Fn, and W cosine theta. Those two forces have to sum to zero because there's no motion in that dimension. Well, to sum forces, we have to define a direction. I'll define upwards as positive. So the normal force is a positive force, W cosine theta is negative. Well, to sum those two forces then, I just take Fn plus negative W cosine theta. Those two forces have to add to zero. Well, that means that Fn equals W cosine theta. And we know W and we know theta, so we can calculate Fn. Fn equals W, 35 newtons, times a cosine of 30.0. That's 3.0 times 10 to the 1 newtons. I have to use scientific notation here because I need two significant figures. Alright, so that's the normal force. Why did we calculate it? Because we need the normal force to calculate friction. Friction is the coefficient of kinetic friction times the normal force. Well, now that we know normal force, we know both of those things. Friction equals the coefficient, 0.12, times the normal force, 3.0 times 10 to the 1 newtons. That works out to 3.6 newtons. Okay, so we now know friction. That's an important point. We need to remember it. The frictional force is 3.6 newtons. Now we can finally look at the parallel dimension where the acceleration is going on. The sum of the forces there has to equal mass times acceleration. To sum the forces, we need to define a direction. So let's define motion down the incline as negative, so motion up the incline is positive. That means friction is a positive force and W sine theta is a negative force. So when we sum the forces, we have F plus negative W sine theta equals mass times acceleration. Now we can just fill in the numbers and solve for acceleration. However, before we do that, I need to make a quick point. I did not give you the mass of the block. I gave you the weight. The weight is 35 newtons. We need to convert that to mass. I'm going to assume you know that by now. A weight of 35 newtons is a mass of 3.6 kilograms. So I'm going to replace weight in the list of things we know with mass. Mass is 3.6 kilograms. Now we can go ahead and solve the problem. Friction is 3.6 newtons. Weight is 35 newtons. The angle is 30.0 degrees. The mass is 3.6 kilograms, and we don't know A. When we solve for A, we find that it's negative 14 kilogram meter per second squared over 3.6 kilograms. The kilograms cancel, and the final answer is negative 3.9 meters per second squared. What's the negative mean? It means the box is sliding down the incline. Remember, we define down the incline as negative, so a negative acceleration simply means accelerating down the incline.